Agricultural Bank of Namibia's Agri-Advisory Services Division offers training to farmers and bank clients in various farming enterprises in all 14 regions of Namibia through face-to-face sessions. The Agri-Learn online platform will share production content on various agriculture farming enterprises to build the knowledge of farmers from all walks of life. Join us as we embark on this virtual journey towards sustainable farming, as we zoom into the basics of farm infrastructure.
Good day, farmers. I am John Venter. I'm a livestock mentor from Agri-Advisory Division, Agribank, and I want to talk to you about water pumps and the installation of water pumps. So when you look at the bottle behind me, then to think about which pump you want to install in this bottle, it all depends on the source of energy that's available. So every water pump needs some source of energy to driven on the drivers and to driven on the water pump, to power the water pump. So when you look at the sources that are available, at first look at the nature, and you can make use of the wind and make use of the windmill. And also together with the windmill, you can also, the other one that you can use, other source is the diesel engine or maybe the petrol engine. And also you can get some manual of manpower, and you work with manual. But you can think by yourself too, the manual pump is working with a cylinder and the piston pump, and you're pulling it up or down, or maybe you can turn it around. But the manual pump is not for commercial use. It's not for giving animal water. It's only for domestic use, small villages where people are coming to get water in buckets, maybe for domestic use. So if I look at the windmill itself, the windmill is making use of the cylinder and the piston, a type of pump. And the windmill is maybe a reliable source of pump. It's very economic, and maybe it's a very long lifespan. So maybe should be your first choice for when pumping water. But also the windmill have got its limits. If the water is too deep, then the windmill doesn't working well. So if I look at the pump itself, this is the cylinder, and this is the piston is there inside. So when the windmill is turning around, then the connected windmill, it will up and down, and it will pumping water. So inside your cylinder is working with leather couplings of washers, and sometimes this couplings is wearing out, and you have to replace it. The biggest problem with the windmill is even if there's the smallest hole inside the pipe, or maybe the foot valve here on the cylinder itself is a very, very small leakage, then your windmill is not effective anymore. So when I want to connect it, I also can connect the windmill and the power head together. This is the power head standing behind. So when I connecting the pipes here, I need steel pipes and I need steel rods. So I connect the rod with the rod from the cylinder, and I connect the rods up inside pipes, and I connect steel pipes above to bring out the water through the pipes going out to up to the above. So I can use the power head, but I connect the pipes to my force head, and the rod I connect to the power head, and then I can pump water. So this is a very good choice, but I also can use a diesel engine. And this is, you have to think twice when you think about diesel engine, because it's very expensive. And also the high fuel prices, it make it not so economic at all. But if you have other sources of energy, like manpower, grid electricity, or maybe a generator, or maybe from the solar, then there's other options that you can use to pumping water. If you have got grid electricity, then maybe the best choice will be the submersible pump. If you look at the submersible pump, it's standing out. This is the motor, it's driven on by electricity, and the pump is above. And so the motor is running around, and there's a lot of small buckets inside here. And when they're running around, they're taking the water from one bucket and throw it to another bucket. And so it's pulling the water up to above, And when you look at what you need a plastic pipe. There's no steel pipes needed, no steel rods needed. It's only pipe. And you need electrical cable to take it up and to connect it to your electricity on top. And therefore you need a control box to put it on top. And this one controlling the starting and the stopping of your submersible pump. What is always advisable to put above your submersible pump, you put on a water sensor. So if the water level is going too low and the water is coming to the water sensor, immediately the sensor will stop the motor and it's preventing from burning out. So this electrical motor should never be running dry. If it even running dry once, they will burning out. So you have to make sure that put on the water sensor, ask for a water sensor by the connection. So the electric cable going up, but this is very heavy. This motor is very heavy, therefore you need a thick nylon rope to hold it and to tighten it on top of your barrel and make sure that your pump didn't drop down inside in your barrel. When I'm coming back to my cylinder, and I will show you the end on this power head, the windmill and the power head has some different strokes. And you have to make sure that the stroke of the windmill or the stroke of the power head could fit in the size of your cylinder. So your cylinder should be long enough so that the stroke can go up and down inside your cylinder, that you not damage your cylinder or broken your rods inside there. Also adjustable with your submersible pump, you can use a float switch. Now the float switch, because you have electricity, you connect it in your control box, and also you connect it, you put it inside in your water reservoir. So when the reservoir is dropping, water is lower down, you adjust it here. You can adjust it here, and when the water is lower like this, then immediately the pump running by itself automatically. And when the water reservoir is becoming full, becoming this level, the pump automatically will stop. So this is advisable to put it in when you have electricity. But also you can have it solar power. And when you look at solar, it's the same than the submersible pump. But the difference between the two pumps, the submersible pump is running with 240 to 380 volts. And the solar pump is running from 15 volts direct current to 150 volts, it's more or less volts. And it looks basically like the same, and you need basically the same. You need the electrical cable, you need the nylon rope. It's also plastic pipes, it's not steel rods and not steel pipes. It's very easy to put inside your barrel, very easy to take it out. And the other thing that you need your PV panels. The maintenance on the solar pump is very, very low. The only maintenance that you have there is to make sure, and once in a while, take a cloth and you clean your solar panel, your PV models. To make sure it's clean from dust, clean from bird droppings. But when you look at the solar pump, you should make sure that there is, if you're going on farm pipelines, then it's not preferable to say, yes, you can use it. It's only when you pump around your homestead. But it's very, very good when the water is very low and the water delivery is very poor. Then that is advisable to put in a solar pump. So if I look behind me and I see here, also this pump here is driven on by electricity, by electrical motor. This is not so a favorite option, because to transfer the electricity from the motor back to the power head will take a lot of energy away. So maybe the best option is here. There's a very weak barrel with a very poor delivery. Either solar pumps will be the best option here, and not the electrical motor is standing behind there. Okay. But if the water is very, very poor, the delivery is very, very poor, then the submersible pump is not to be adjustable and to be favorite to put in. Okay, so when your water is very, very deep and you've got very strong water, then you can put in a mono pump. This is your other pump, but it's very, very expensive. But if you're going for irrigation and you're going on pipelines and you have a lot of water to give on your farm, and the borrow is very strong and very deep, then the best option will be the mono pump to put in your borrow. Okay, before you going further on, you need some information before you're buying a pump, because there's a specialized field. And you can't go into a shop and say, yes, I want a pump, and look in the shelves and say, yes, this one will fit me my best. For my price, I take it. Now you need some information to take with you when you're going to buy a pump. And the first one is you should know what is the delivery of this bottle. And the second one, the delivery means is how much water can this bottle produce in 1 hour, can deliver in 1 hour. And every bottle has its own limits. You can't exceed the limit of the bottle. That's why you have to make sure you put the right pump, the right size pump inside the bottle, so you don't exceed the limit of the bottle. So the first one is how many water can the bottle deliver. The second one is what is your water level? How deep is your water? And when you look at your bottle from top, you've got soil on top, and then you've got the water level. And when you're starting water, then the water is lower down. And when you're coming lower down, then you come in, the stream is flowing in, then you come into your delivery. But when you test the water level, you have to take out the pipes, you have to open it there and take a nylon rope, put a bottle of a little bit of water inside plastic bottle, and you put it down and you feel where's the water level, and you take it out and you put it on the ground with your tape, and you do the measurement and see, yes, maybe my water level is 30 meters. And maybe my delivery of this bottle is 1,000 liters per hour. And the next thing that you need is the height that you want to pump. So if I'm standing here, and I look at the water, I have to go to the water tank above. Then the stand is 6 meters, and the tank also is another 2 meters. So the height that I want to pump is 8 meters. And the last thing that I need is the distance that I have to pump. How far will I pump? Where's the end where I pump? So this is close to the water tank. But maybe I'm going on a pipeline to a water post, 2 to 3 kilometers. You need special advice, and you have to get the advice of your extension officer. And they will assist you to do the survey for the pipeline. And they also will do the survey and tell you in what pump will be the best for you. So you have to make sure that you get all this information. Take this information to the supplier, and he will give you the right pump for the right use that you want it for. Okay, I will now demonstrate you when I'm talking about the stroke. So how can you look at the stroke and make sure that your cylinder is adjustable for the stroke that's going inside there. So when you have got some of the power heads, you've got a long stroke. And on your power head, you look at the national power head is standing at D9 or the D12 or D18. It means it's 9 inches is the stroke. Or D12 is 12 inches is the stroke. Or D18 is 18 inches is the stroke. So you have to make sure that your cylinder is long enough therefore. So I will start the engine now, and you can have a look at the stroke and see what I'm meaning with the stroke is running up and down. When you look at the diesel engine, you have to make sure that you also get advice, and special advice for your diesel engine. Because the person who gives you advice will tell you how much horsepower the engine should be, and what should the kilowatts of the engine should be, and what should the revolutions of the engine should be. So you can't go and buy an engine and think this engine will serve your needs at your bottle. So make sure you've got all the information before you're going buying pumps. Okay, you can also you can use the windmill together with the power head. But the power head and the windmill can't run at the same time. So you have to disconnect one of them. On this stage, the power head is disconnected and the windmill is connected. So if you've got a water problem and you need to pump with the engine, then I disconnect the windmill and I connect the power head. So I take off this rod, I take another short rod inside here and I put it through there, and then I lock the two nuts. I lock it there and I'm connected again with my rod below, and then I can start, and when my power head is running around and the windmill is away, then I can use the engine. So this is the easiest way to, when you are also in water very deep, then you can use the windmill and the wind is not blowing too much and you get water problems, then you can use the power head together with the engine. It also, this windmill is feed the pipeline. There's no dam is closed here, so the pipeline is going and they have to, from plus minus 2 kilometers from this side to one water reservoir, and about 3 to 4 kilometers from this side to another water reservoir. But on the far reservoir, we put on the float valve. So when the dam is full, then the water comes back and the water pump to the other reservoir. And when you look at the pipeline going along, because you've got an uneven flow here because of the power head, therefore you need the air vessel. So this is the air vessel, and this should be always full of air and not full of water. This is why the tap is here. So you have to drain the water. You see there's no water inside now. And when the pump is pumped, then there's some type of compression up here, and he changed the uneven flow to an even flow. So he converted it to an even flow is going through. When you also look here at the borrow in the pipeline, you see there's a one-way valve. So it makes sure that the water coming from the pipeline will not coming back to your borrow, and that your pipeline should be always full of water. And this is why you need the one-way valve, so the water can only go in one direction. Okay, I will demonstrate now. I'll open the windmill, so the windmill can run. Then you can see how the windmill is working inside the power head, but the power head is standing still, so you can't use them on the same way. So one should be disconnected, the other one should be connected to work. Okay, this is the brake lever from the windmill. So when I turn it up, you see the tail of the windmill is close down to the wheel now. So when I loosen this, the tail will coming away, and now the brake becoming loose, and then the wheel will start turning around. And you have to turn it up slowly, and not when you loosen it, you leave it, and the tail is coming quickly, it's coming outside. Okay, we also talk about the stroke of the windmill. And every windmill have got a different stroke. This is how high that it's lifting up and how far it's going down. This is the stroke of the windmill. And that's why you have to match your cylinder, your piston, your cylinder, that it's long enough to match with the stroke from the windmill. This is your faucet. So the faucet makes sure that no water is spilling around on the windmill. So when the water is coming out and the water is leaking out here, you have to tighten it here a little bit, and then you put the rubbers close to the rod, and the water will not spill around around your pipes and your power head and your borrow. We are now at the windmill, and the windmill is coming here, pumping the water with the pipeline to this water dam. And in this water dam, we got the float valve, and when the dam is full, the float valve will close, and the water will pump into another water dam. So the windmill is feeding two water posts and water points. And that's why the use of the float valve inside the water dam.
That's it for now. Join us next time for more valuable insights. Make sure to subscribe to our YouTube channel to avoid missing out on new content. Also, follow us on Twitter, Facebook, and Instagram pages for more content.